Look at any official map of the world, and you will quickly notice something missing. The United States government does not officially recognize the Bermuda Triangle. There are no agreed-upon boundaries. Depending on who is telling the story, the borders flex and stretch to allow for a 1 million square mile margin of error. This reputation began growing 500 years ago, long before airplanes existed, with Christopher Columbus in 1492. Sailing through the region, Columbus noted strange phenomena in his logs. He documented ocean sea levels rising to immense heights and a small, faint light flickering on the distant horizon, and, highly unsettling for a 15th century navigator, erratic compass readings that drifted away from true north. When these sailors returned to Europe, their stories trickled out. By the time a British resupply ship wrecked off the coast of Bermuda a century later, the region already had a reputation as a cursed patch of water, a reputation potent enough to inspire William Shakespeare to write The Tempest. Centuries of unverified sailors' fables layered on top of one another. Each new account was viewed through the lens of the last, slowly cementing the region's status as a geographical anomaly. Fast forward to the 1960s. The Cold War is peaking, the Cuban Missile Crisis is fresh in the public mind, and widespread paranoia has created the perfect environment for conspiracy theories to thrive. An American author named Vincent Gaddis officially coined the phrase the Bermuda Triangle in a 1964 pulp magazine. But it was this man, Charles Berlitz, who recognized the true commercial potential of the frenzy. In 1974, Berlitz published a book that sold 20 million copies. He did it by taking routine nautical accidents and explicitly attributing them to UFO abductions, time portals, and the lost city of Atlantis pulling ships into the murky depths. The world bought into this terrifying pop culture-driven narrative. But when we strip away the science fiction paperbacks and run a strict audit of the data, we find a reality that looks entirely different. To understand the physical reality of the zone, we have to look at the atmosphere. The Bermuda Triangle sits squarely inside a high-risk hurricane alley. Florida and Puerto Rico routinely absorb direct hits from destructive tropical cyclones, more frequently than almost anywhere else on Earth. The weather systems here are uniquely violent. Then, there is the water itself. The western edge of the triangle is dominated by the Gulf Stream. This swift, turbulent ocean current flows up to 300 times faster than the Amazon River. If an inexperienced crew miscalculates their drift, the force of the water can shift a vessel hundreds of miles off its charted course. And if a disaster does occur, that same rushing water quickly scatters the debris across the open Atlantic, erasing the evidence in a matter of hours. Ships and planes aren't vanishing because of something supernatural. They are succumbing to extreme oceanographic currents acting on normal maritime wrecks. The same physical rules apply to the sky. Take the Triangle's most legendary aviation disappearance, the 5 Navy torpedo bombers of Flight 19 that vanished in December 1945. The official naval radio transcripts paint a very clear, mechanical picture of what happened. The lead pilot, Lieutenant Taylor, explicitly radioed that his compasses were malfunctioning. Taylor became completely disoriented. He reported that he was flying over the Florida Keys, but analysis by ground staff proved he was actually entirely wrong. The squadron was far to the east, near the Bahamas. Believing he needed to turn east to reach the Florida mainland, Taylor instead ordered his squadron to fly further out into the deep Atlantic Ocean. They flew aimlessly until their planes ran out of fuel and ditched into the sea. When the transcript data is mapped against the environment, the disappearance is revealed as a tragic, verifiable case of human disorientation. To finalize this risk audit, we need to calculate the actual danger of passing through this zone today by comparing its casualty data to the rest of the world. This chart breaks down a dataset of over 150,000 marine casualties recorded between 1982 and 2015. Out of all global maritime incidents during that 33-year period, the Bermuda Triangle accounts for exactly 4%. We can get even more granular. Lloyd's of London tracked 8,634 boats passing through the Triangle in 2021. Only 2 suffered casualties. That is a failure rate of 0.02%, massively below the global shipping casualty average of 1.8%. Statistically speaking, you are 90 times less likely to experience a marine casualty inside the Bermuda Triangle than the global average. The National Transportation Safety Board Aviation Database confirms the exact same reality in the sky. Since 1962, there are 0 statistical anomalies here. The few accidents on record strictly correlate with poor weather decisions by pilots or standard takeoff errors. You combine a massive volume of commercial traffic with severe tropical weather, and accidents will inevitably happen. But the hard math definitively proves the point. The Bermuda Triangle is statistically unremarkable and objectively safe.